Algebra I 12.7a, equation of joint variation. Okay, we're at 12.7a. Before you watch this video, please watch 12.5a and 5b and 12.6a. They talk about direct and inverse variation. If you don't know what those are, you're going to get confused. So spend a few minutes by going into the links in this video's description, and you can just click on them and watch them real quick and come back to this one. All right? So when a value is based on two variables jointly, it's based on them together, we have a joint variation. The formula for the area A of a triangle is A equals half BH. That B is the base of the triangle. See the green base? And the H is the height. And the half is that constant, the constant of variation. Well, in this formula, the area varies directly as the base and height. If the base and height are decreased, the area will be decreased. If the base and height are increased, the area inside of the triangle will increase. See? Our definition is an equation of the form z equals k, that constant, times x times y, where k is a non-zero constant. It can't be a zero. That shows joint variation. And joint variation relates at least three quantities. You can see them. 1, 2, 3, and we have our constant. So distance varies jointly as rate and time. That's three quantities. The total cost of items will vary jointly as the price per item and the number of items purchased. That's three quantities. So it says at least three quantities. So we could have 4, 5, 6, 10, 20 quantities. We just add more variables. We can find an equation of joint variation where V varies jointly as B and H. So this V is going to vary depending on what V and H are doing. Okay, so in the first set of information they give us, they say V is equal to 35 when B is 7 and H is 15. And we can use these values to find V when B is 18 and H is 6. We find K for this one and plug that value for K into this one to find the V. So we substitute the first set of given values to find the value of K. Here's our equation of joint variation. V equals K, the constant, times B times H. Well, in this one, we've got 35, 7, and 15. And plug those in to find K. 35, 7, and 15. Well, 7 times 15 is 105. So now we've got 35 equals K times 105. We can isolate K on this side of the equal sign by dividing both sides by the 105, right? Because that's the inverse of multiplication. This is multiplication. And we get 35 over 105 equals K. K times 1 is K. We can divide both the numerator and the denominator by a 3 to simplify it down to 1/3. So now we know that the constant K is 1/3. We're going to use that to find V when B is 18 and H is 6. So now our equation for joint variation is V equals 1/3 BH. We plug in our values of 18 and 6 from the second set of information, and 18 times 6 is 108. So now we've got 1/3 times 108. Well, that's the same thing as 108 divided by 3. If we did 108 over 3 by multiplying it, we'd still have to figure out how many times 3 can go into 108, right? And it goes in 36 times, so we know V equals 36. So we used these first set of values to find K, plugged that value for K into the second set, and solved it. Now, sometimes there's more than three quantities. We can find an equation of joint variation where W varies jointly as X, Y, Z. Now there's 4. We've got W is going to equal that K times X times Y times Z. See? We've got a first set of values that we can use to find the constant K. We can plug that constant into the second set of values and solve it. So we use the first set given values and make an equation of joint variation that's W equals K constant times X, Y, Z. We plug in the values that were given us from the first set, 3, 5, and 6, right here. And 5 times 6 is 30, times 3 is 90. So we've got 36 equals K times 90. We can divide both sides as an inverse operation to isolate K to one side of the equal sign. We got 36 over 90 equals K. We can simplify that to 2/5, or we could simplify it to 4/10 if we want it as a decimal. All right. Now we're going to plug this value in 2/5 for k to find when x is 2, y is 8, and z is 5. 8 times 5 is 40, times 2 is 80. 2/5 times 80 comes out to 32. We do our math. We get 160 over 5. 5 goes in 160 32 times. So we know that w is now equal to 32 for this second set of values. All right? So we had 4 quantities. We had w, and we had x, y, and z, and our constant k. And those 4 quantities were related. All right? And it doesn't matter how many quantities we're given, we still need to find k to solve it. All right? So our next video is going to be 12.7b. We're going to talk about combined variation. And of course, through this whole chapter 12, we've been talking about relations and functions. And all the videos that are related to this one, like the ones I asked you to watch in the beginning, and anything to do with functions, there's going to be a link in this video's description. So if you're confused right now, you got ahead of yourself, you need to go into the description of this video, scan through this list, and start watching the videos that you don't understand, okay? For the concepts you don't understand. Hopefully that'll clear things up, and if you're completely confused, my advice is to go back to the video of 12.1 and start watching from there, all right? I'll see you next video. Keep trying. We can do this. Bye.